Hi, doing a quick video on the quotient rule for calculus. Here we go. The quotient rule, we're in chapter 2.3, the quotient rule, and it states this. If we have the derivative d with respect to x of f of x divided by some g of x, then we get g of x times f prime of x minus the quantity of f of x times g prime of x. And many times what I like to do is I'm going to put this second piece in a set of brackets. Not a very clean bracket, hold on. Clean bracket there for us, because I want to make sure that if there's some binomial or polynomial, I distribute that negative. All divided by g of x squared. All right, this is used when we have a quotient of two differentiable functions when g of x cannot equal 0. So we can't get a 0 down here, otherwise it becomes undefined anyway. All right, so let's take a look at example number 1. It says 5x minus 2 divided by x squared plus 1. That's our y value, so we label it f of x and g of x. Then, come over here, we have g of x is x squared plus 1 times the derivative of f of x, which is just going to be 5, minus the quantity of f of x, 5x minus 2 times g prime of x, which is 2x, all divided by quantity of x squared plus 1 squared. We distribute, step 2, after we took the first derivative, we distribute, and so we get 5x squared plus 5 after distributing, minus, I'm going to do the inside the bracket first, we get 10x squared minus 4x, all over x squared plus 1 quantity squared. Okay, moving along. We combine like terms and simplify if possible. So after we combine like terms, we distribute the negative. We get negative 5x squared plus 4x plus 5 all over the quantity x squared plus 1. If we could factor this and see if we could get an x squared plus 1 out as a factor, then we would do so. However, in this case, we can't, so that is where we're done. All right. Let's look at example number 2. A little bit more interesting. We've got a square root involved, so here we go. Move down this way a little bit. Come over here. There we go. All right. So we have the square root of x is our f of x. X cubed plus 1 is our g of x. So here's our reminder of where we're going. G of x times f prime of x minus f of x times g prime of x. Again, I will put this in brackets so we know to make sure we take care of that. Any negatives we have to distribute through. All right, so g of x, x cubed plus 1. F prime of x, we should know by now how we treat a radical x. And that's just 1 times x to the negative 1/2 divided by 2. And I'm leaving it in that format for a reason. We'll get to that in a second. Minus the quantity. In this case, there is no binomial, so I don't have to really worry about distributing too much, but we'll still keep it in green for a moment. Okay. Divided by the quantity x cubed plus 1 squared. There's no reason to FOIL this or anything yet because we're not getting there. Now, once I distribute, I get 1/2 times x cubed. X to the negative 1/2 plus 3 turns into x to the 5/2. Okay, I challenge you to stop the video, remember your rules of exponents. When we multiply two like bases, we add the exponents. 3 minus 1/2 would be 6 over 2 minus 1/2, or 3 would be 6 over 2 minus 1/2 would give you 5/2 in the numerator and 2 in the denominator. Then we get x to the negative 1/2 in the numerator and 2 in the denominator. Once I distribute that to 1 minus 3x squared, and x to the 1/2 turns out to be negative 3x to the 5/2. Okay, and we get to the bottom here, x cubed plus 1 squared. Haven't done really too much. I want to get rid of these 2's. So what I decided to do is I'm going to multiply top and bottom by 2. That will eliminate anything here in the denominator. So let's move along. When I multiply this by 2, it gets rid of these two 2's, so we notice we come up here, we get x to the 5/2 plus x to the negative 1/2 minus 6. That 6 came from 2 times negative 3 is negative 6, and we get x to the 5/2. So we rewrite it like that. And since we multiplied the denominator by 2, I got to put the 2 out there. So that's where that 2 came from. Okay. Next level is I'm going to combine. I can combine this x to the 5/2 and another x to the 5/2. We can combine those, and we get x to the negative 1/2. That's there. And then minus, if I have negative 6 and I add one of them, same thing, I subtract and I get negative 5x to the 5/2. Now, another means of simplification is I can factor something out. X to the negative 1/2, because that's there. When I factor out something, remember, factoring is like dividing. So you have to think of these exponents as like dividing. So 1 minus 5x cubed. Now, urge you to stop the video, figure out if you divide 5x or just x to the 5/2 and divide that by x to the negative 1/2. Okay? If I go, let's do it really quick. If I say x to the 5/2 divided by x to the negative 1/2. Remember, when we divide by exponents, we actually subtract them. So it will be minus 1/2, right? 5 minus minus. And that will give us x to the 6 over 2, which is x cubed. And that's how that happened. All right? So now, coming back here, that's how I get negative 5x cubed. 2 is down in the denominator. X cubed plus 1 squared. Haven't even done anything with that. No need to at this point. The only thing left to do is bring this thing that I factored out, x to the negative 1/2, into the denominator, and that shows up there as the root x. So we get 1 minus 5x cubed divided by 2 times the square root of x times the quantity x cubed plus 1 squared. And that's it. That's the answer. That's all you got to do. Okay? It's really not that bad. Well, I hope you've enjoyed watching this quick little tutorial on the quotient rule. It's great calculus fun. So enjoy. Have a great day. Talk to you soon.